always recording, okay? So this is going to, this, the same orientation, in, kind of stuck over here. This hole, right?
Oh, wrong.
Line up with this. They'll have about a I'll talk for the rest as it happens. Yeah, a little bit heavy.
I got him. Oh, go with him. Go with him.
So basically, we have to mix 15 grams of each of these here. And we're mixing popsicles.
Back it up,
grab those. Mix it up. We'll put it in this container to degas.
Okay, so
and then
inside of here is the liquid material. The top is kind of has
just like not the whole diameter, but like.
So that's where the oxides are poured, right?
First, you're going to weigh out 15 grams
aside, right? So what you're seeing here is not exactly tin. It's tin oxide, it's antimony, it's a little bit of copper. We don't want that. This pouring technique, we actually pour from the bottom. Normally, when we have a furnace running, we pour from the top.
So you weigh one at a time.
The straw gets in the way. This process, we're pouring from the bottom, and allows us to forego all of that. So what you're going to do is you're going to lift up this handle, and you keep on lifting until you see a little silver button formed out.
Ooh, so keep on lifting.
Wait, how big is the thing?
So right now it's filling up the cavity.
Keep lifting.
Yeah, keep lifting. Doing great.
This is so cool. Like, I like this.
All right, perfect.
Ooh.
All right, so I'm gonna let that cool off. Now, keep in mind, this one is the coldest spot in the entire mold.
Wait, why is that?
Because it's the furthest away.
Oh, so that's the harder.
Yep. So this one you can see is starting to shrink. Right? These are both kind of bubble shaped. They could explode. It's going to start shrinking, and then that bubble is going to go from this shape into this shape, right before your eyes. And then we just keep it in there for a few minutes, so you can actually see crystals forming.
Right, start at 0. And be careful when you pour it. Kind of like.
Well, the wait like 5 minutes, give or take, and then we'll crack it out.
And if your gloves are dirty, don't touch things. Throw the gloves down when you turn.
Very, very warm. So we're going to kind of speed the process up and free it from its prison of MDF. All right. So normally when you have we deal with castings, you have to be concerned about the insulating properties of the mold itself. So the thermal conductivity, the mass, the surface area, very important, as well as the mold itself, as well as the ambient temperature. For the time being, you'll be all right. So use this, you're going to wedge in there, too. This you do is kind of like get them in between and twist like that. Hold. I'd say keep one glove on for holding.
Yeah, I mean, if you're interested, take a look at the chemical composition of epoxy.
So it's right here.
Yeah.
Chlorine in there.
Girl.
There we go. Okay. There's one. And then let's keep this one as a placeholder. There we go. And the other side.
Forcible.
Oh, there we go. And maybe one side here. All right, let's see. Lovely. Oh, this is perfect, right? Beautiful. So you can see, obviously, poured on this side where it's nice and hot, and it's cool over here. So this is the original material, right? This has been allowed to cool off very slowly, likely in an oxygen-free environment. So these two lusters and colors match. This has a discoloration on it. This is the same effect that happens with oil on water, okay? This is thin film interference. So inside the mold, there was a bit of oxygen, and as it cooled off, it bound itself to the metal, but at certain temperatures, that thickness, the layer of that thickness grows, right? So it's thick, you get things like here, right? They're nice and purple, or less than you get the straw color, okay? So again, the oxide layer is very thick at that point, but it's really thin right here. So welders, when they're doing their welding business, they can tell the temperature of the metal as it was welded when it gets contact with air based on the color. So if I wanted to, I can just sort of scrape it off. right? So it's just the oxide layer that forms that makes that color, right? So, yeah, and let's see.
That's so fire.
Okay, see that?
Boy, she was cool.
So, as it's cooling though, let's find out here. If you look, you can look right on the top. You can see those two little divots right there. That's where it kind of fell into itself, right? Isn't that neat? So let's take the temperature.
Check. No, because I checked.
Plenty hot. Actually, this is pretty warm too. Look at that. This is still retaining. This is it cools off very quickly.
Say like hot when you go. Man's so quiet. That's how you cause a problem. That's how you burn someone. You never.
You don't see me burn anyone?
You never seen the menu?
I'll burn you.
Or like Shameless? Girl.
Not that hot. It's like
150.
Whoa.
Wait,
You heard that? Sizzling?
didn't he say 50 degrees? That's like,
150.
oh, he said 150. I thought he said 50.
Girl.
No, but he said the block was like 120 or 140.
Wait, Doug. How long till one?
Grab it.
Now what you have to do is you've got to cut off that.
Cutting time. That's my time.
Sorry, I'm here.
You sure it's that?
You want the dog?
You want the dog? Yeah.
Like,
You want this one?
You know, I
this
want
one.
to
You
use
want this one?
You sure? It's not this one.
So we're cutting this and this, right? And the other side.
You got it, man.
Alright.
That's
why I wanna use
well, you
this
should
one.
probably be wearing a safety goggles.
That's true. I mean, I got goggles. I thought
It's right there.
Not those.
Oh, right here. Did he get hurt?
Huh? Two hands is a good idea.
That's what? That's what I thought.
He's going
Hold this. Righty tighty. That's like opening it a bit more.
I know, I want to
Make it straight. How much you bench?
I've done too much.
Okay, I'm just gonna
Where'd the phone go?
for every episode you help me. Can I put it over here? Same more example.
That's why you couldn't even drop it in the sink.
It was hot. You want me to burn myself?
It was 150 and you had gloves.
Safety is important.
150 doesn't even boil water.
Yes, it is.
Yes, it does.
150?
150
Fahrenheit?
Celsius.
Celsius.
Oh, that's a different.
I'm going to make you go to the hospital. You don't get a video to tell my first
He won't even meet me outside.
I think he wasn't.
You can take the big saw now.
Okay, anyways.
Anyways.
I've never used it. I volunteered to do the cutting.
What are we doing?
The edges are like out.
Uh-huh.
when you
Oh,
cut it.
okay.
Oh, you bent it.
You bent
You
it.
bent it.
I did not bend
Give
it.
it like.
No, if you want to make it straight, we put it in again. I'll make it straight. Yeah.
All right.
Wow, how original.
All right. So we're gonna put this into the jaws.
That's a DHB.
So you're gonna put that into the jaws, and you want the jaws to grab the widest section of the jaw bone, right? Because we're gonna pull it apart. Yeah. Well, no, 90 degrees.
The other way.
Like this, right?
No.
Rotate.
No, rotate.
On the Z-axis.
Yeah.
Oh, you mean like this?
Wow, he's so smart.
There you go.
Oh, like.
Right into the jaws.
Ah, that makes sense.
It's a senior mechanical engineer, guys.
He's a BSc.
Oh, same thing.
No, it's not the same thing.
I bet you he's gonna apply for
Okay.
something.
And now we're gonna tighten the jaws on it. So I tighten this one that way.
In my mind, mechanics do everything. And BSc is everything.
And civies.
No.
Guys, we went on the field trip on Friday.
What? Yo, look at the graph.
The graph is the same curve.
Yeah. Take a look at the units are different.
Megapascal and kilonewtons.
I cleaned my apartment and installed a bidet.
Whoa.
Europe, very like everywhere has bidets in Europe. They actually usually have like a separate, like they'll have a toilet, and then next to the toilet they'll have like a little basin, and then it's like a bidet, like a, it's not an ad.
Always that was like one of those
Curve is going down.
Bidets are a lot cheaper than Korean.
Yeah,
And it's like a lot more environmentally
friendly, and it's also better. Like it
So
actually
it makes
cleans
sense
you.
that the toilet paper industry would not be against
So
it.
completed pulling. Let's see the load. There's no load on it anymore, so the part broke. So we're good. We're ready to go. Just to finish the method, you click the finish line flag. Yep, click that. It's gonna generate a bunch of files. I'm gonna send that to you all later. Just click yes for the next team. And yeah, you're good to go now. Ratio mix.
Okay, 1-to-1 ratio.
So we're gonna do 15 grams of each. Okay. So let's turn on the scale first. Alright, so it's gonna, once it goes in, we're gonna put this on there. And actually, this is over, that's okay. You just make sure you mix the same amount for the next one.
Yeah. I mean, I kind of fucked up, like the way I studied. Yeah. I could have studied a lot better.
Same thing.
Did you weekend?
Oil slicks.
No,
Yeah, and then we can just do this.
I wasn't focused on the right stuff. But
Perfect.
yeah.
Okay, and now we'll do
His old tests
the next one.
Like my friends
Same
had.
thing.
So this should be 30.
If I got them.
30.
Yeah, or
very smooth sample. That's like a mirror finish. So this would be a really good manufactured part.
What
So-
number do we want? Do we want one?
No.